So when we create an algorithm, we follow certain steps. Okay, and you can see this with the math problem. You can even apply this to the dishwasher. We follow these steps when we're creating an algorithm, and there are three basic steps to creating an algorithm. Deconstruction is the first step. And in the deconstruction step, what we do is we take the problem. Usually an algorithm is to solve a complex problem. So we take that problem and we try to break it down into simpler problems. And this will sound familiar to you because we've already started talking about this in this class. I just haven't given it these labels yet, and I haven't said what it is we're doing. But you take the problem, and if you say, that problem feels too complex to do in my head or to do in one step, like the big math problem, or maybe even the small math problem if you're like me. So it takes more steps. So you got to break it down. Can I break this down into simpler things, into simpler problems? And then once you've reached a stage where all of your problems, all the pieces of the problem are broken down into simpler problems, then you begin solving those one at a time. You solve the simpler problems during the solving phase, and then finally, during a reconstruction, you take the solutions for those smaller problems and you figure out how to put them together so that they represent an answer to the big problem. But that's how we accomplish really complicated things. Like when Amazon tries to predict what I'm going to buy next on Amazon based on what I've bought in the past. Okay? And for those of you that think that's new, that's a very, very old concept. And in fact, it goes back into the mid-90s, actually. I had a friend who was working at a company called Mobile Planet, and they sold mobile phones back before we had a Verizon and an AT&T store on every corner. And in that period of time, he was actually doing if you bought a phone, you might want a charger kinds of sales on that website. So that goes way back, but that was a much simpler algorithm back then. Nowadays, it's much, much more sophisticated with a whole lot more data. So deconstruction might be looked at like this if you're a visual person. Let's say I have this, we'll call this a bento box, right? With the lunch in it. And inside this bento box, I have containers that have various kinds of food. And, maybe I don't like those kinds of food to mix, so I have them in separate containers. And sometimes even containers inside the containers. And so if I want to eat this lunch, what I typically do is I take all the containers out and I lay them out, and then I can address each thing individually. So deconstruction is kind of like that. I'm taking it apart, and I'm seeing even things like this. I'm like, I could break this down a little bit more, right? I can take it apart. And now when I have it broken down into very simple things, then I can solve those things one at a time. I can tackle those problems one at a time. And then finally, once they're all solved, I put them back together. And if you notice, the reassembled version of this is in the same place, in the same pattern as the problem was before. And the reason I'm pointing that out is because a lot of times the reconstruction phase is very similar to just doing the deconstruction in reverse. So you want to look at what did I do to take it apart, and you'll see how to put it back together. And I'm actually going to demonstrate that with the email thing